Good morning. Like I mentioned to you last week that I'm not going to be here for the week of May 2nd. And so I decided to record all the lessons that you're going to need for that week. And we're going to run this class like I did the Thursday 7.1 session, where I recorded the class and had you view it on YouTube, and you come in and do your work in class. That way you'll have no homework to do. There'll be a sub here called Mr. Jager. He's an ex-mission teacher, so obviously his math skills are way up there. He used to teach Calculus BC. So if you need any help, I'm sure he's going to be able and willing to help you out with your problems. What I do want you guys to do, though, is to view the videos before you come into class and start working on your homework. And all that work is going to be collected at the end of the period, just like we did last week on Thursday. So if you go to my website, you'll see this file called CP Pre-Calc Agenda, May 2nd through the 6th. The file essentially tells you all the sections and all the work that needs to be done during the week of the 2nd of May. So today I'm going to record 7.2. Okay. The lectures will obviously not be as entertaining because we don't have entertainment from the likes of Eileen or Beta or Krakow and Cindy, and probably also entertainment from Hao Fang and Matt. So it's going to be just me, the laptop, and Matt. Okay. So we're going to do solving systems of linear equations. Yeah, this is 7.1. Let me just scroll down to 7.2. So we're going to be dealing only with linear equations in 7.2. And I think in 7.1 we learned three methods of solving systems of equations. And here there's a fourth method that's been introduced or will be introduced, and that is, if I can position this right, and that is matrix algebra, which is this guy here, okay? Which I think happens in 7.4. So just let's go over all the things that need to be talked about in 7.2. And we've done methods of substitution in 7.1. We've done what's called elimination, and it's also called linear combination. We've done graphical, and then like I mentioned to you earlier, there's going to be matrix algebra that we're going to use to solve systems of equations, and that comes up in 7.4. So what I want to talk about is, first of all, the number of solutions in a linear system. Okay, so there are three possibilities here, as you can see. Okay. So remember, linear systems are really systems where you can actually graph them and you get lines. Okay? So there are three situations that may happen. The first one is the lines may be parallel. Okay? And that would mean that there are zero solutions. Okay? That'd be zero solutions because the lines are parallel. Then the other option would be that the lines would intersect, okay, and they would intersect at only one place, okay, they would intersect only at one place. For example, here, okay, it intersects just there, and therefore there's only one solution, and that's how graphically you'd see that. You've got a third case, okay, where the lines are really, there are two equations typically, and they both represent the same line. So the lines are sitting on top of each other. Okay, they're sitting on top of each other. And therefore, you've got an infinite number of solutions. Okay, you've got an infinite number of solutions there. So those are the three cases in linear systems. Okay. There's a word called consistent that's going to show up later on in the lecture. And consistent means that it's a system of equations that has at least one solution. So again, remember that a system of equations is nothing more than a set of equations, and in 7.2, what we are going to be dealing with is really linear equations. Okay. All right, so let's do some examples. First one is solve by elimination and check algebraically. This is number 12 on page 491. And let's just go work on that. And so here are your two equations. I typically like to number my equations so that I know what's going on. So here's 1 and here's 2. And it's asking us to do it by elimination. So I guess the best variable to eliminate would be r, and the best thing would be to times the first equation by a negative 8, so that you get negative 16r here. Negative 32s equals negative 40. You would add these two equations, okay, add the two equations, and this would cancel. This would give you 18s equals 15. So s is equal to 15 over 18. Always reduce. So that's 5 over 6. So that's s. We need to find r, and we can do that by plugging it in this equation, or plugging s in that equation. And what I get is 2r plus 4 times 5 over 6 equals 5. And working this out, you get 5 minus, reduce this, so this becomes 2 and this becomes 3. So it becomes minus 10 over 3, which is 5 over 3. Divide by 2 and you get r equals 5 over 6. So your pair of solutions would be r is 5 over 6 and s is 5 over 6. And it's asking us to check algebraically, which means that we need to go back and plug it in, and make sure that it's working. So take this and put it in there, take this and put it in there, and let's see if you do get a 5. So it becomes 2 times 5 over 6 plus 2 times 5 over 6. Notice I'm not going to say it's equal to 5. I don't know if it is, okay? So this is going to be 3, this is going to be 3, and I get 10 over 3, and I have clearly smoked somewhere. Okay? Should get a 5 there, right? Oh, sorry, my bad. This should be a 4. Okay, so then that should be 2, and this is 15 over 3, which is equal to 5, and that is indeed what I expect. You also need to go check in the second equation. Do not just rely on working on the first equation only, because you don't know what might happen with the second equation. So going and checking that out, you get 16 times 5 over 6 plus 50 times 5 over